behavior, turning points, zeros being your x-intercepts, if your graph will bounce or cross at that x-intercept. So those were the pieces from Friday. So looking at today, the very first thing, you may not necessarily need to write all this down. Let's kind of paraphrase and figure out what we need to write down here. So we have the intermediate value theorem. So if you have a polynomial function, and if for two numbers a and b, the values of p and a and p and b are opposite signs. So just take a second, we'll talk about it, and then we'll kind of paraphrase what you need to write. So it's saying I have two x's, and when I plug them in, I get different y values. One y value is positive and one y value is negative. Then that means that somewhere in between those, your function has to equal 0. So our paraphrase, let's say in a polynomial, if p of a and p of b are opposite signs, a 0 exists between a and b. You can draw yourself a little picture, but essentially if I know that I have a positive and a negative y value, since a polynomial is continuous, somewhere in between my function does equal 0. So I have a polynomial p of x equals x cubed minus 2x squared minus x plus 1. And I want to show it has a 0 between 2 and 3. To do that, the first thing we're going to do is find the y values when I put in both a 2 and a 3. So if I plug in a 2, it gives me 2 cubed minus 2 times 2 squared minus 2 plus 1. Okay, work that out, and what does that give? What do you get? -1. All right, let's plug in a 3 and see what we get. What does that give you? 7. So what we see, -1 and 7 have different signs. So there is a sign change. So a 0 exists between 2 and 3. So there is some number in between 2 and 3 that will make this function equal 0. Now, if I wanted to find that number, we could use our graphing calculator to help us. So we are going to graph this function. So I want you to go to your y equals, plug in x cubed minus 2x squared minus x plus 1. If I wanted to find it exact, we've done this before in our calculator. We set our y2 equal to 0. I'm looking between 2 and 3, so I'm going to go to zoom number 6, zoom standard, and just reset my window. So here's my polynomial. We're looking between 2 and 3. It's that 0 right there. If you set your y2 to equal 0, we could find it exactly. If you go to second trace number 5 intersect, remember doing this on our last test? First curve, just hit enter. Second curve, just hit enter. Guess, I'm looking for the point between 2 and 3, so I'm going to scroll over there. Hit enter. And what does it tell me that value is? 2.25 approximately. Okay, so on tonight's homework on our Math Excel, sometimes it's just going to say use the intermediate value theorem and see if there's a 0. If I plugged in 2 and 3 and both of them came out to be positive, that doesn't prove to me that there is a 0 in between. But if one's positive and one is negative, then there is. And then if I ask you to find it, you can use your graph to look.
Did you have a question? Yeah, I just did not get that. The first time I did it, I got like,
Usually you get close to that one. So you got closer.
okay, so is it like in the middle?
The second curve, you just hit enter. First curve, it's okay. Just hit enter. Okay, anyone else need calculator help?
I did.
First curve, hit enter. Second curve. You didn't say your y2, just if you're going to do this, yes, because you have to have a first curve and a second curve. First curve and a second curve. Yes. Yeah, if you're going to find an intersection. Okay. You didn't enter at 0 for your y2. Yeah. So there you go. Second trace intersect. First curve enter, second curve now it jumps enter.
Oh, there it is.
Yes, get
It wasn't showing that.
closer. Okay. So here's a question for you. If they are the same sign, does that mean there is not a 0? So I plug in two numbers A and B, and let's say they both give me a positive value. Does that mean there's not a 0 in between?
No.
No. My graph could have came down and done something like that. So if they're the same sign, it doesn't tell me that there's not a 0, but it doesn't tell me that there is. Basically, if they're the same sign, we know nothing. We only know anything if they are opposite signs. All right, any questions about that?
We're going to say no solution for that?
You would just say we can't prove there's a 0. The next thing that we want to get into is synthetic division. So we are going to use this to divide polynomials. And I think the easiest way to review synthetic division is to actually just do an example. Is that okay with everybody? So here's what we're going to do. We are going to divide 5x cubed minus 6x squared minus 28x plus 8 and divide that by x plus 2. So when we do this, synthetic division, if you remember, is a way of quickly doing a division problem. So it's the alternative to long division. It doesn't work all the time, only if you're dividing by something that's linear, which x plus 2 is, so you can't divide by an x squared or anything with synthetic division. In this, we first look at what we are dividing by, and we have to find the 0 for that. Sometimes it's called the k value. It's just the 0. So x plus 2, what's the 0 for that? -2. Would you guys agree? -2 equals 0. So that's like my k. So you put that number outside a little box. Next, we are going to put just our coefficients. So I have a 5, a -6, -28, and +8. In that, you have to watch. If you are missing any powers of x, you have to put zeros. So, for instance, if I had said like 5x cubed plus 4x, I would have to put my 5, I would have to put a 0 for my x squared, I would have to put a 4, and then I'd have to put a 0 for my constant. So watch on the synthetic, if you're missing powers, you have to do zeros. Okay, skip a line and draw your equal sign. So with synthetic, the very first step is the first number comes all the way down. So 5 drops down. Then it's just a series of multiply and add. So 5 times -2, -10. Add -6 plus -10, -16. And we're just going to repeat this. -16 times -2 is 32. -28 plus 32 is 4. Multiply. 4 times -2 is -8. 8 plus -8 is 0. In this, the last number always represents the remainder. Then you have your constant. It's just then increasing power. So this would be an x and an x squared. So the answer to my division is 5x squared minus 16x plus 4. And I don't have a remainder, so I don't have to include that.
So what if you did have a remainder?
If my remainder was like a 10, you put plus 10 over what you divided by, which was x plus 2. Okay, do you guys remember doing this at all?
Yes.
Okay, good. So for what we're doing, we're talking about polynomials. And when something has a remainder of 0, that's actually really important to us. What that means is if it has a 0, it divides evenly. So in terms of the graph, -2 is an x-intercept on my graph. Or we could say the x plus 2 is a factor. So the factor theorem, you probably want to jot this down. If you have a polynomial, x minus k is a factor if and only if f of k equals 0. This is really important, so jot that down, and then we'll look at this. So we have to know the difference between what's a factor and what's a 0. And we even use that on the homework from when we were talking about that graphing problem for today. So I want to make sure we are clear on that. A factor includes an x. So a factor is a sum or product, well, let's say sum or difference involving x. So factors are things like x plus 3, x minus 5, x plus 1, x minus 4. Those are factors. It's x plus or minus a number. A 0 is just a single number. So the 0 is like your x-intercept. So if it's x plus 3, what would be my 0? Negative 3. If it's x minus 5, my 0 is positive 5. If it's x plus 1, my 0 is negative 1. If it's x minus 4, my 0 is positive 4. So when I'm talking about a factor, if I tell you to give me the factors, you have to put the x with it. If I want the 0, you're giving me just the number itself. Okay. You find those things the same way. It's really just how you answer the question. Do you put the x with it or not? Questions there? So let's look at some more examples. I'm really not doing any new content for the rest of the stuff, just phrasing my questions differently. So for this function, 2x cubed minus x squared plus 2x minus 3. I want to know if x minus 1 is a factor. So if it's a factor, what does that mean? So this is a factor because it's involving the x. If I'm wanting to know if it works for this polynomial, that's essentially just asking you, is it going to divide evenly? So we have to figure out if this works. There are multiple ways to do this. One way is just the synthetic division. When you do the synthetic division, you have a 2x cubed, negative 1x squared, a positive 2x, and a negative 3. The number that goes out here in the box is a 0. If I have x minus 1, what goes in my box? 1. Okay, so I'm going to do this synthetic. So my 2 comes down, multiply, 2 times 1 is 2. Add negative 1 plus 2 is 1. Multiply, you get a 1. Add, and we get 3. Multiply, we get 3. Add, we get 0. So remember, this is your remainder, your constant, your x squared. So this is 2x squared plus x plus 3. But I just have to answer the question. If it's a factor, what that means is it divides evenly. So is this one a factor?
Yes.
Yes. It came out evenly. The remainder was 0.
Will it always be 0?
If it's a factor. If you get another number, then it's not a factor. So if I want to check if x plus 2 is a factor, what do I put out in my box? Negative 2. We're going to do the synthetic with that. So the 2 comes down. 2 times negative 2 is negative 4. Add, we get negative 5. Negative 5 times negative 2 is positive 10. Add, and we get 12. multiply, that's negative 24, add, and we get negative 27. So is this one a factor?
No.
No. If you don't get a 0 there, it's not a factor. I didn't ask for it, but if I wanted the quotient, the answer to my division problem would be 2x squared minus 5x plus 12 minus 27 over x plus 2, if I asked for that. So if you get a remainder, it's not a factor. Okay. Is that all right for everyone? If I ask the same question a different way. I'm trying to show you all the different ways you might be asked, and I'm really just asking you to do the same thing every time. I want to know if 2 is a 0. Okay, I asked if it was a 0, so I didn't have the x with it. But all I'm asking you is, does 2 divide this evenly? There are really two ways of doing this problem. The first option is just what we have to do, synthetic. If I give you the 2, what number would you put in your box? Actually, if I give you the number, that's the number you use. Because you always put the 0 out there, so if I've already given you the 0, you just keep it. My coefficients will be 1, negative 4, 9, and negative 10. So 1 comes down, multiply, and add. Multiply is negative 4, add we get 5, multiply we get 10, add we get 0. So is this one a 0? Yes. The other alternative for these problems is that theorem that I had you write down, the factor theorem. Look at that real quick. It said that for a polynomial, x minus k is a factor if and only if f of k equals 0. Plug in that number. If you plug in this number, it actually gives you the remainder. If I put a 2 into this, I get out 0. Which in this case, since I didn't ask for the whole quotient, I just asked if it's a factor or not. That's all I really need. On this one, part B, we could do synthetic with a negative 2, or we can just plug in negative 2. What do you get? So is it a 0?
No.
No. Okay, I don't care how you do the problem as long as you can get to the answer. All right. One last slide, and then we're stopping for today. I want to know if x plus 4 is a factor of each of these. So, same question, just asked a different way. I want to know if x plus 4 would divide it evenly. So my options. I can either do synthetic division, and what would I be dividing by? Negative 4. Or, since all I really care about is the remainder, I could plug in negative 4. Which way do you guys want to do? Plug in. Yeah.
So when we plug it in, do we have to put like x to the third in there somewhere because it's not up there?
If you did synthetic, you would. If you're just plugging in the negative 4, you do not. So if you find f of negative 4, you guys have calculators, so you're going to calculate this one for me. I don't really want to. Tell me what you get. You get 0. So what does that mean? It's a factor. All right. plug it in on B. Find f of negative 4. Alright, what'd you get this time? Negative 40. So what does that mean? Not a factor. Are there any questions about this? Alright. So the Math Excel assignment is posted, due by the end of the day tomorrow. It's twofold. It goes back over the stuff we were talking about Friday. So the first half of it is just asking you questions about in behavior and things like that. Second half is asking you questions like this. Is it a factor? Is it a zero? Okay. If you're planning to do the test corrections, make sure you come see me during advisory, get a pass if you need to, and you've got the rest of the hour to work on